Okay, so the most important part from page 586 is this right here, the y equals kx. Now there's two ways of doing all of these direct variation problems. Now I'll show you both ways, and then we can decide which way we'd like to use later. All right, but I always want to show you both ways of doing something. The key that you're looking for here is if you ever see these words, varies directly. When you see the words varies directly, it is a direct variation, and the first thing you do is write this down, y equals kx. Okay? K is a constant. It will always be the same throughout the problem. But generally speaking, you have to find it first. Okay? It's never given to you in a problem, ever. So you will almost always have to find K first and then use that K throughout the rest of the problem. So this is definitely a multiple step problem. All right. I want you to notice a couple things first off. I'm over here. Y equals mx plus b. Does that look very similar to y equals kx? Kinda. What's the same and what's different? Okay. Okay, the y and the x. You've got...
X is being multiplied.
Okay.
There's a multiplication.
In y equals mx plus b, what does m stand for? Slope. In y equals kx, it's the slope. It's the same thing. Okay? But what is there? You just said it. What is there missing? Y-intercept. So the y-intercept is 0. On a direct variation, direct variations are lines. They are lines with a constant slope. All lines have a constant slope. All right? But they are lines, and it's constant. And that's where the K comes from. Just talking about that is a constant relationship. Okay? Direct variations are your level 1 thinking. Okay? If something doubles, everything else doubles. That's constant. That is very direct. If something goes up, everything else goes up. That's very constant and very direct. That is a direct variation. They're your easiest ones. Okay? We're going to study some harder ones in a minute. But what I want to do right here is I want to take y equals kx. I want to solve it for k. How do I solve this for k? Divide by x on both sides. And I just found out that k equals y over x, right? Okay. That's an important relationship. Y equals k over x. Excuse me. K equals y over x. Because now I always know how to find my constant k. My constant k is going to be the ratio of the y over the x. Now, how do you apply that? Well, you just look at problems like this. This is pretty much a straight out of an algebra book problem, and then this will be a straight application problem. Okay, so let's look at how those two things go together. Again, this is from Math 1. As soon as you see these words, what do you think? Y equals kx. So as soon as I see y varies directly with x, then I write down y equals kx. It's the first thing I do. Now, this second part of the equation, or the second part of the sentence, I should say, it says y equals 20, or negative 20 when x equals 4. Well, what they're trying to tell me there is I can plug those in and I can actually find k. So let's plug in what they've given us. They're telling me that y is negative 20. Bless you. When x equals 4. Okay? Is this an easy enough equation to solve? Can you find k? All right, we can find k, right? I'm going to divide both sides by 4. And I just found out that k equals negative 5. What does k represent again? Oh, I don't think I wrote it down. It is my slope. I'm sorry, I didn't write that down. I got ahead of myself. K is the constant. Okay? It is the slope. You're absolutely right. But in a direct variation, we normally use the word constant. I'm sorry about that. It's called the constant of variation, sometimes called the constant of proportionality. All right? So K is my constant. Okay? And now, remember, it's called a constant because what does it do? Or what does it not do? It doesn't change, does it? So now that I know that it varies directly with x, and I used my green information here to find my constant k, is that k going to be the same throughout the rest of the problem? Yeah. So now I can come over here and I can use that k to figure out what's missing. Okay, so I'm going to rewrite my equation. Remember, y equals kx, but now don't I know k? Yeah, now I know k, so I'm going to plug in the k is -5, and didn't they also give me x? So is it possible to find y? Easily. So all you're going to do is have to multiply y equals +30. I want you to remember that k is called a constant because it's not going to change throughout the problem. So the background for this is easy enough. The background is when I do my green k, I know from right here that k equals y over x, right? So in green, I can find out that my k is going to equal my y over my x. Now I did that in green, but I'm going to put y1 and x1 as well. Now in blue up here, I also have another relationship. Doesn't k still equal y over x? It's just a different y and a different x, right? So I can do that same relationship again, but this time I'm going to call it y2 and x2 because it's a different set of points, right? But what did not change in either one of these? K didn't. That's exactly right. K is constant. So this k is equal to this k because it's not going to change. It's constant. So in other words, the green k equals the blue k, or the green y1 over x1 equals the blue y2 over x2. And what did I just create? I just created a proportion. How many of you like solving proportions? I know some people like them because they're easy. Cross, multiply, and divide, right? So they're pretty easy, aren't they? Well, look back at the problem and help me fill in the blanks for y1, x1, y2, and x2. I'm just going to do it. Well, help me fill in the blanks. y1 would be -20 over 4 is x1. And y2, I don't know y2, do I? But I do know x2 is -6. So y2 over -6. Is this easy enough to solve? I hope so. So I could just cross multiply. Y2, I'm sorry, it's getting a little, it's in that gray area. But is it easy enough to solve? It should be, right? So I'm just going to do 4y2 equals, what's -20 times -6? +120. And then solve and you get y2 is 30, and look at that. Same answer, right? It doesn't matter to me which way you do it, but you got to know one of them, right? Some people are going to prefer the proportion. All direct variations are based off of proportions. That's fine. But I will tell you, in science, you're going to want to be able to find k. And this doesn't really give you k as much. It really does. I mean, -20 over 4 is k, and so is, I can't read it anymore, but so is this answer here. Okay? But you're going to want to know k. All right, we know the circumference of a circle varies directly with its diameter. Now, that's super important. As soon as you see those words, you think y equals kx. But you know what? This is a word problem. And there's not a y and there's not an x in the problem. Let's not use y's and x's. Circumference, what do you think? C. C equals kd. Is that okay? All right, that makes much more sense for this problem. So let's plug in. We know we've got Jack and Jill right here. When Jack's trying to figure this out, he found out that the circumference of a circle was 157 when its diameter was 50. So according to Jack's information, we can plug that in and find out k. So let's see, his circumference is 157. It's going to equal k times his diameter, which was 50. Is that easy enough to find k? What would k end up being? Try again. 3.14. All right? It's 3.14. I hope you recognize that. Okay? Now, how can that information help Jill? It says, what should Jill find the circumference of a 35 diameter circle to be? So now Jill has to use the information that Jack found out. How's she going to do that? She's going to plug it in. So for her, she's going to find the circumference equals K, which she just found out was 3.14, times D, which for her is 35. And what does she find her circumference to be? I'm sorry, I didn't hear you. 109.9. Okay? Now, obviously I chose this problem on purpose. K, the constant, you recognize the constant? All right, most of you recognize it as approximately pi, right? 3.14. And guys, that is the relationship. Maybe you didn't remember that, but C equals pi D. Isn't that the formula for circumference? It is. Okay? So, if you would have remembered that, you could have skipped the whole problem. But it is a direct relationship, and that's what I wanted to show you. It's a direct variation. If it's a joint variation, if it's a direct variation, we'd say y equals k times x. But now it's going to be a joint variation, which means more than one variable at a time, so it's kx z. All we did was add an extra variable. Look, y equals kx is direct with x, and y equals kz is direct with z.
Does it have to look fancy?
What do you mean look fancy?
You're a Z.
Oh, well.
That's just how you write Z.
I was just trying to make it not look like a 2. All right. Okay. So, as soon as we see y or r varies jointly as v and t, I should immediately think y equals kxz, except I'm not using x's and y's. What am I using?
K's and X's.
V's and T's.
I'm using r's. I should have just left that there.
R's, V's, and
I'm using r varies directly with k v t. All right. So the z's are gone. No problem with z's. All right. So now I've got to read this part over here. This part does read a little bit funny. It says find r when v is 2 and t is 8 if, and then it tells me a different part. It tells me r equals 70 and t equals 4. Which one is giving you more information? The green one, right? The second one? That's the one you need to use first. Okay? So I need to start with the one that gives me the most information, and that's this one. So fill in what you know. What do I know? Let's see. R is going to be 70 when k times my v is 10 and my t is 4. Is that easily solvable for k?
Yes.
Sure. 10 times 4 is 40. And then, of course, k is going to equal, you could leave it as a fraction or decimal, probably a decimal here. What do you think? 1 point, was it 1.75? Yeah, 1.75. All right. Okay. Once you know that, now you can use that information in the second part. So, once again, go through it. Y equals, not y, excuse me. R equals kVt. Except now I know what k is, right? So it says find r, so that's obviously my variable. K is 1.75. V is 2. And t is 8. And this one's just old plug and chug. Go right to your calculator. 1.75 times 2 times 8. 28. As soon as I see the words varies jointly, I need to be thinking about the old y equals kxz. But I'm not going to use kx and z. What am I going to use? I'm going to use E for energy so I don't get the K's messed up. K, M for mass,
And
V squared. It does say the square of the velocity, so that is a V squared, so that's a good catch. All right. So at this point, I should be able to fill in my blanks. They give me a mass and a velocity and an energy. So let's fill those in and let's see what K is equal to. That'd be 100 ergs. I don't know what an erg is. 100 ERGs equals K times the mass, which was 8, times the velocity, which was 5. And what do I have to do that velocity? Square it. It's part of the formula. So order of operations, 5 squared is 25, and then 25 times 8 is 200. So I've got 200K equals 100, and I hope I got room to write, well, I don't. K equals 25. No, 0.5, sorry, 0.5. 1/2, right? K equals a half. Well, you just wrote a formula. What formula did you write? You just wrote energy equals. It's no longer a K because you just found K. What is it? It's 1/2 times the mass times the velocity squared. You just wrote a formula. Okay? And now use that information to help you solve. As I read my second part, it says find the kinetic energy. So I'm obviously finding the energy for a mass of 6 and a velocity of 9. So E is going to equal 1/2 times my mass of 6 times my velocity of 9 squared. I hear click, click, click. 1/2 times 6 is 3. And then 3 times, this is 81. 3 times 81 is? All right, 243. Oh, that's the wrong page. All right, so here's what we're looking at. Just like before when we had direct variations, you can actually have an inverse variation, which is the opposite of it. So instead of y equals k times x, it's going to be y equals k divided by x. The x is going to be in the denominator. Yes, ma'am? As soon as you see the words varies inversely, you should immediately think y equals k over x. But this one's not k over x. It's really a equals k over b. So that's what we're going to use. Now, it says a is 24 when b is 4, right? And a says find a when b is 12. So I'm going to start off with the most information that I have, which is this information. So I know that a is 24 when something k divided by 4. So find that something. Multiply both sides by 4, and what does it have to be? 96, right? K has to equal 96. So my constant of variation in this problem would be 96. Now remember, a constant is constant. It doesn't change. So if it works for the orange, it'll work for the green. So I'm going to switch over to green and do the same thing. This time I'm supposed to find A when K over B, so that's 96 over 12. So what's 96 over 12? Is it 8? Yeah. All right. So as I read here, it says in kickboxing, it is found that the force F needed to break a board varies inversely with the length L of the board. Okay, as soon as you see the words varies inversely, what should you think? Okay, y equals k over x, but I'm probably not going to use a y and an x. F equals k over L. All right. So plug in what you do know. What did they give you? Looks like they gave you 5 pounds of pressure will break a 2-foot board. So let's use that information to find K. So I now know that the 5 pounds of pressure, 5, has to equal some number K divided by 2. So what is K going to be?
10.
K is 10. So my constant of variation is 10. Now if it's constant in one, it's constant in both. So use this 10 to help you find out about this 6-foot long board. So F is going to equal K over L, but of course now I know what K is. It's 10 over 6, which is 1.6 repeating. All right, as I read here, variable M varies directly as variable T, but it varies inversely as variable S. So I've got two different variables going in two different directions, don't I? So let's talk about it. If I were to write M varies directly as T, how would you probably write that? All right, you'd say M equals KT. Is everybody okay with that? All right. If you were going to write M varies inversely as S, how would you write that? M equals K over S. Well, look, are these two M's the same? Are those two K's the same? Okay, these are the same stuff, so put them together. Put it together. Okay? If you look right here, M equals K times T. If it says K times T, that's direct. K times T is direct. This says K divided by S. K divided by S is inverse. So is my direct variation and my inverse variation happening at the same time? It sure is. It just depends on the variable.
What would it be like y equals kx over what?
All right. We know that M is 24. We don't know K yet, but we know that T of 3 and the S of 2 will help us get that M of 24, right? So follow your order of operations, solve for K. Your inverse order of operations, solve for K. Yeah, you'd multiply both sides by 2, right? So that's going to be 48 equals 3K. And then K has to be 16. Now you know what K is. Use K to help you find the other situation. So use K to help you find that. So now I know that M is going to be 16 times 5, 16 times T, divided by S, which is 8. And once again, order of operations, 16 times 5 is 80 over 8. M has to be 10. So we're going to take a small shortcut on this last one. I'm not going to actually solve for the height of the tree, what it asks for down here, but I do want to write the formula, the science formula. And that's really one of the most important parts that science wanted to know, is they want to know the actual formula. So as I look at this problem, it tells me the volume of wood in a tree varies directly as the height and inversely as the square of the girth. Okay? So help me write a formula that would represent that. Volume equals, it varies directly. As soon as you see varies directly, you know you've got a K somewhere. KH for the height, because it varies directly with the height. And it's over G squared. Why is it G squared? Okay, it does say the square of the girth, so G squared. So this would be almost my formula. It's not my formula until I know K, because K is a constant. So if I can go ahead and find K, then I'll have an actual formula that I could use on any problem. So I do need to go ahead and find K, and that will give me my formula. So plug in what you do know. It looks like I know that the volume of a tree is 144 when the height is 20 and the girth is 1.5. So we'll plug those in. 144 should equal K times the height of 20 divided by 1.5 squared, right? Yeah, don't forget about the g squared. So order of operations, 1.5 squared is 2.25. And then, of course, you're going to multiply both sides by 2.25. So what's 144 times 2.25? 324. I'll trust you. And then K will equal 16.2. I'll trust you on that too. So how does that tell you my formula? I can come back to my formula now and write that down. My formula is actually V equals, it's not KH over G squared, it's actually 16.2 H over G squared. And that got a little sloppy for space, but